Hello everyone, welcome to the channel StatisticaHub. So in continuation with the lecture series of IITJAM 2023 paper, in this lecture we are going to discuss a few more questions regarding that. Okay, so let's just see firstly the question number 55, and the next question that we will do is question number 58. Okay, so let's see it. Question number 55. It is saying let x1 is equals to 2, x2 is equals to 5, x3 is equals to 4 be the observed values of a random sample from a population having a probability mass function f of x comma theta is equals to theta 1 minus theta to the power x if x is equals to 0, 1, 2. Okay, where theta belongs to 0, 1 is an unknown parameter. If tau cap is the uniformly minimum variance unbiased estimate of theta square, then 156 tau cap equals. Okay, so in this question we have to find out the uniformly minimum variance unbiased estimator, that is UMVUE. Okay, so yeah, so let's just see this. Let's firstly, what is the given information in this question? So we have given x1 which is 2, x2 which is 5, and x3 which is 4. Okay, and we have also given the probability mass function, that is f of x, which is theta 1 minus theta to the power x. Okay, for x is equals to 0, 1, 2, like this. Okay, now if you remember this thing, then isn't this like a distribution? It is my, what is this? This is my geometric distribution, right? So this will be the geometric distribution with the parameter theta, right? Now we got the distribution, that this is the distribution that we have. Now we have to find out the UMVUE for theta square, right? That's the task now. Okay, so for the geometric distribution, if you find out the sufficient statistics, okay, like when you are in the exam you won't like do the proper procedures to find out the sufficient statistics. When you do so many problems in the in statistical inferences for these kinds of problems, you already know that what will be my sufficient and statistics. Okay, so we all know for the geometric distribution T is equals to summation xi, that is the complete and sufficient statistics for theta, right? We know this. T is equals to summation xi is the complete and sufficient statistics for theta. If you want to check whether this is sufficient and complete also, okay, so apply the property of the completeness, and for the sufficient statistics, firstly you will see the sufficient statistics, whether it is a sufficient statistics or not. So for that you can apply the likelihood function. So you'll just apply the likelihood and you will be getting something T is equals to summation xi. So it is saying that it is your sufficient statistics. For the completeness, you can also do the same process for checking whether this is a complete statistics or also or not. Okay, so yeah, but yeah, we don't need waste our time in checking portion in the exam. We just directly say that this is T is equals to summation xi, which is my complete and sufficient statistics, because we already know this. Okay, now this summation xi, what is this? Summation xi, this is the sum of geometric random variables. Okay, that's what it is. Like xi are following geometric with the parameter theta, and summation xi is the sum of it. Okay, so what would it follow? Summation xi, T is my summation xi, so now it will follow negative binomial n comma theta. That's the property, that sum of geometric follow negative binomial. Okay, now we have to check whether this, we have to find the UMVUE. Okay, so for finding out the UMVUE, we got that this is the sufficient statistics, and we know the distribution of the sufficient and complete statistics. So this is following negative binomial n comma theta. Then what would be the PDF of it? That is, let's say ht by theta. So the PDF corresponding to it is t plus n minus 1 ct 1 minus theta to the power t and theta to the power n. That will be the PDF. I have just written the PDF of negative binomial. Okay. Now we are saying let delta t be a function of t such that expectation of this delta t is equal to theta square. Right? We are using the function of t. It is the function of t to find out the unbiased estimator for theta square. Okay. So what is expectation of delta t? That would be summation t is equals to 0 to infinity delta t, and what is this? Just write down the PDF. T plus n minus 1 ct 1 minus theta to the power t theta to the power n, which is equals to theta square. Okay. Further simplifying, let's just see it here. It is summation t is equals to 0 to infinity delta t t plus n minus 1 ct 1 minus theta to the power t. Now I can transfer this to theta square here, so it will be theta to the power n minus 2 is equals to 1. Okay. Yeah. Now we have this delta t plus n minus 1 ct. Okay. Now from the property of negative binomial, or you can say from the property of any distribution, it is true for every distribution that summation of that f of x is equal to always 1. That is basically sum of probability is 1. So we are going to apply that the sum of probability is 1. Okay. Now let's see, when we are saying sum of probability is 1, that basically means summation. Now see, it is theta to the power n minus 2. Okay. Theta to the power n minus 2. So it would not be true for 0, 1, 2. So my t would start now from 2 to infinity. Okay. Now what are we having function? 1 minus theta to the power t theta to the power n minus t. Okay. Now according to delta t is the constant, is a function of t right now. Okay. It is the function of t. Let's just write it here like this. Yeah. Okay. So I have to make this as a probability, as a function of probability mass function of negative binomial according to this n minus 2. Okay. So I have applied t plus n minus 2 plus 1 ct, and we know that the sum of negative binomial is equal to 1. Okay. So that's my first equation. That's my second equation. That is actually when you know that this is corresponding to delta t that we have used, that expectation of delta t is equals to theta square. Okay. And here we are using the property of the negative binomial, that the sum of negative binomial is equals to 1. Okay. With respect to the same parameters that we have. So now if I compare these constants that we have on comparison, what are we having? We are having t plus n minus 2 minus 1, this would be minus 1, sorry, minus 1 ct is equal to, these are same. Okay. So they will be cancelling out. Now I am just comparing these two functions. That will be delta t plus n minus 1 ct. Okay. That's what we are getting after comparison. So what is my delta t? My delta t is coming out to be t plus n minus 3 ct upon t plus n minus 1 ct. Okay. Let me just remove this portion here. Yeah. Okay. So in this, what we have done, we have taken the negative binomial distribution to simplify all the things that we have, and we have used the property of the probability of the negative binomial, that the sum of negative binomial is going to be 1. Okay. So with respect to it, by using it, we got that the delta t is equal to t plus n minus 3 ct upon t plus n minus 1 ct. Okay, let's simplify it further. So this thing would be tct, like using the property of combinations, t plus n minus 3 ct Okay, because we have, okay, yeah, we have n is equals to 3. See, we have x1, x2, x3, that means n is equals to 3. Okay, so by using this we have tct, and what is this? This is t plus 2ct, right? Now tct, that would be 1, and t plus 2ct. Oh, I'm so sorry, I've been writing t small t for like in every time, but it is going to be capital T. Okay, so I'll just replace it with the capital T here. You can also change. So t plus 2ct. Okay, now what are we having here? We are saying that the expectation of delta t is equal to theta square. And what is the delta t we are having? Expectation of 1 upon t plus 2 ct is equal to theta square. So this is the function of t, right? That is the function of t. Okay, now we remember that by the help of Rao-Blackwell theorem and the Lemon-Chaffee theorem, what do they say? Okay, we are having this delta t which is a function of t. Okay, and that is also complete and sufficient statistics. So by using Rao-Blackwell, what does the Rao-Blackwell say? That any unbiased estimator is improved with respect to variance by an unbiased estimator which is function of sufficient statistics. Okay, and also what does the Lemon-Chaffee say? The Lemon-Chaffee says that if you have y which is complete sufficient statistics for theta, and if you are having some function of y which is unbiased estimator for that parameter theta, then your phi y is UMVUE, right? So by using this property, what are we having? We have t which is summation xi, that is completely sufficient statistics for theta. Okay, now we are having delta t, that is the function of t, and we are getting that it is the unbiased estimator of theta square. So this is my UMVUE. Okay, that is tau cap is equal to 1 upon t plus 2 ct, right? Now what is t? T was summation xi. Okay, summation xi, what is that? Summation xi means we have x1, x2, x3, that is sum of 2, 5 and 4. That is going to be 11, I think, right? Okay, so this will be 1 upon 13c11. Okay, you can solve it, simplify it. So that would be 1 upon 13c2. Okay, simplify it, that is 1 upon 13 into 12 into 2 into 1, that is 2, 6 are 12, 1 upon 78. Okay, and what do we have to find out? We have to find out 156 tau cap, that is 1 upon 78. Okay, so that would be, I think, twice of it. Yeah, so we got the answer that 156 tau cap is the result is 2. Okay, so yeah, now see the procedure what we have done in this question. Okay, in this question the main task is to find out the UMVUE. Okay, and we already know that whenever we need to find out the UMVUE, we are going to use the properties of the Rao-Blackwell and Lemon-Chaffee theorem. Okay, but yeah, the small things that you notice, that you should know that what does the sum of geometric follows. Okay, same thing goes for the other distribution. The small properties that you should know these properties. If you don't know this, then it would be like hard for you to do these kinds of questions. Okay, so yeah, that's it in the question number 55. That is the completion of this question. I have seen, like told you the whole procedure, that what is happening in this question, but when you do it in the exam and you know the concept, then it would not take that much time. Yeah, sure, of course, but I'm telling you the whole procedure right now. Okay, yes, now let's see the next question. That is question number 58. What is it saying? Yeah, so let x1, x2 be a random sample from uniform 0, theta. Where theta is greater than 0 is an unknown parameter. For testing the null hypothesis H0, theta belongs to this thing. against theta which belongs to 1 comma theta, consider the critical region, that is this, then the size of critical region equals. Okay, so we need to find out the size of the critical region. Okay, so let's see what we have given. We have given x1, x2 which are uniform 0 comma theta. Okay, and we have the hypothesis that h naught, which is theta, belongs to 0 comma 1 union 2 comma infinity, against the alternative hypothesis, that is theta belongs to 1 comma 2. Okay, and we have also given the critical region corresponding to it. Okay, now what is the critical region? That is, size of the critical region means I have to find out the type 1 error. Okay, so I have to find out type 1 error here, alpha. Alpha is my type 1 error. Okay, so what is type 1 error? Type 1 error is probability rejecting h naught when it is true. That's what my type 1 error is. Okay, so I have already given the critical region, so I can use it. That my critical region is 5 by 4 less than maximum of x1 comma x2 less than 7 by 4, and when h naught is true. H naught is true means we are going to take the theta corresponding to the null hypothesis, that is theta belongs to 0 comma 1 union 2 comma infinity, right? That's what it is. Okay, now see what is maximum of x1 comma x2. So basically this thing is actually x of 2, right? That is the maximum of x1 comma x2. So firstly let's see that what is the PDF of this f of x2, right? So that is the f of x2. What is the PDF of this portion? Okay, so we can find out the PDF corresponding to it, that xi is following uniform 0 comma theta. Okay, then what is f of x? That is, I don't need to show it, but yeah, x by theta. And if you find out the order starts, like it is the use of order starts basically. So f of x 2 theta, that would be here 2x by theta square. Okay, 2x by theta square. Okay, that is for 0 less than x less than theta. That's the PDF corresponding to it. Okay, so we have got the PDF corresponding to it now. Okay, and what do we have to find out? We'll just compute it. 5 by 4 to 7 by 4. I'm not gonna put the value of the theta right now. We'll just put the value of the theta in the end. Okay, like after understanding why we are putting that particular value. Okay, so for now we are just computing that in that integration part, that is 2x by theta square into dx. Okay, so 2 by theta square, that will be x square by 2. Okay, 5 by 4, 7 by 4, that is 2 by, okay, 2 and 2 will cancel out, and we will be having 1 by theta square and 49 by 16 minus 25 by 16. Okay, so yeah, 1 by theta square, that's a very simple calculation right now that you can do very easily. The main task is what value should I choose for the theta. Okay, 24, so it would be, yeah, 3 by 2 theta square. That's what we are having. Okay, now I just want that someone give me the value of the theta and I'll get my result. Okay, that's what we need to do right now. Okay, now let's focus on our theta. We have given the theta that is belonging to 0 comma 1 union 2 comma theta. Okay, and for our f of x2, what is the range? That is 0 less than x less than theta. Okay, for this is for x2, 0 less than x less than theta. Okay, now see it in this way. You are having 0 less than x2 less than theta. Okay, that's what you are having. Now in this, whatever, okay, we have unit theta which is belonging to 0 comma 1. Okay, now the range, they are asking the range for 5 by 4 less than x2 less than 7 by 4, right? That's what my range is. Okay, now let's look at it very properly. This 5 by 4, I can write it down as 1 plus 1 by 4. Okay, this 7 by 4, this can be written as 1 plus 3 by 4, okay, less than theta. So basically x2 within this range, sorry, I'll just write down this again, that 0 less than 1 plus 1 by 4 less than x2 less than 1 plus 3 by 4 less than theta. Okay, so whatever be the value of x2 is, it would be between 0 and theta, and we have to find out the probability corresponding to this range. Okay, yeah. Now see our theta. Theta is union of 0 comma 1. Okay, now 1 is in the there is a closed interval on the 1, so 1 is included. So let's say if I put 1 here, if I put theta is equals to 1, then what will happen? If I put theta is equals to 1, then 5 by 4 and 7 by 4, these are not in the interval. Okay, because my 0 less than x2 less than 1, then it would be this. Okay, but these are the properties which are greater than 1. You see, that's why to show this portion we have divided them into two portions, like 1 plus 1 by 4 and 1 plus 3 by 4. So if I am putting theta is equals to 1, then this range, this interval is not included in this 0 comma 1 interval. Okay, because we can easily see that if I put 0 less than 1, then this range is not included here. Okay, because it is greater than 1. So now what are we doing? We are doing, let's talk about theta 2 comma theta. Okay, like when theta belongs to 2 comma infinity. Okay, now there is a closed interval on 2 also. Okay, when there is a closed interval on 2, now see, why am I talking about the closed interval portion only? Okay, that you are having the probability that is 3 upon 2 theta square. Okay, now we are looking at what is the maximum chance of committing type 1 error, right? I am looking at the maximum probability, that what is the maximum chance that I'll commit the type 1 error, right? So for this probability to be maximum, okay, for this probability to be maximum, 3 upon theta square, for this to be maximum, okay, my theta should be smaller. Okay, theta should be smaller. So in this range my interval is not lying, so I will not talk about this. In this range my interval is lying, like I can put 0 less than x less than theta is equals to 2, then yeah, it is lying in that range. Okay, so in this interval 2 comma infinity, we are talking about only 2. Okay, because when I am putting the lesser value of the theta, that is theta is equals to 2, I'll be having the maximum probability corresponding to it. Okay, so because type 1 error says that what is the maximum probability of committing type 1 error, right? That's what it is. So when I'll put maximum value, that is theta is equals to 2, that I will put, because if I'm putting theta is equals to 2, my probability is becoming maximum. Okay, so 3 upon 2 into 4, basically 3 by 8. Okay, you'll just 3 by 8 simplify into the decimal points, and that will be your result for this thing. That will be your size of critical region. Okay, so in this question, what do we have to do? We have to just focus on this portion, like everyone can do it till this part. Okay, this part can be done very easily, but you have to focus on the main thing, that what is the value of theta that I should choose. Okay, so actually everything is in the question only, that they are writing it a 5 by 4 and 7 by 4, so I can easily say that these are the values that are greater than 1, so this interval would be excluded. Now the only point of concern is 2 comma theta, that which value should I choose from this 2 comma theta. Okay, yeah, so these are the question number 55 and 58 that we discussed today. Hope you understood it. Okay, so yeah, that's it for the today's lecture. Thank you. Let's meet in the another lecture.